the moment of force, right? Moment of force, or we call it torque, right? So there's a difference between a force and a torque. There are two things. One is moment of force, the other one is just force. The moment of force is also called as torque. It is also called as torque. Torque, T-O-R-Q-U-E, torque. Torque, right? So there's a difference. A torque and a force are two things, right? So if you apply the force on an object, the object starts to move in a linear motion, right? Force එකකින් එන්නේ හැමතිස්සෙම linear motion එක, right? But when it comes to a circular motion, a force is not enough, right? Force එකක් විතරක් මදි. When it comes to linear motion, force and the perpendicular distance from the pivot point to the force, both are important. So there are two things. What? Force and the distance from the perpendicular distance from the pivot point to the force. That two factors affecting the the circular motion. Why I am saying that, like if you take a, let's come to the stimulation. Now come to the home. Where shall I go? The home source. Yes. See, can you open it? Can you? Make it. Right. So there's a difference, right? Then circular motion negative, a force is not enough. I'm not sure. Then online join in lamint, I don't know. I'll check that, right? So listen, me circular motion negative force එක විතරක් මදි. හරි. Tell me this. Now if you're closing a door, right? Applying the same force, right? When you're closing a door, the door moves in a circular motion, right? A moment. The door moves in a circular motion. So you are applying the same force but in two different places, right? One is from the edge, which is like the highest distance from the pivot point, and the other one is somewhere in the middle of the the distance, right? So what would make the door like close really fast? Applying the force in the edge or from the middle? Edge, right? But you apply the same force, right? But applying the same force in a greater distance made the circular motion larger, right? A greater circular motion was there when you applied the force in a greater distance, right? So for the circular motion to occur, that not only the force affects, also the distance also affecting, right? අපි ගමු make it බලන්නකෝ. I'm not sure if the motion is given here. I'm going to apply this 5 kilograms. Now that is the motion, right? I'm going to put it back. And I'm going to apply this much of a weight here. Do you see it's slow? Motion was slow, right? If you apply the same force in a greater distance, the motion will be, see, it is faster. So that is the difference of a force and a torque, right? So for the circular motion to occur, to make the circular motion more faster or greater in value, that you have to consider the distance and the force together, right? Which we call a torque, right? So a force makes a linear motion and a torque makes a circular motion. Get it? And those two things have like more similar, like they are not similar but they are alike. The alike factors are there in circular motion and the linear motion. So one factor is that in a linear motion the force makes the motion, right? But in the circular motion, instead of torque there's force. Sorry, instead of force in the circular motion there's torque. The torque makes the rotational motion moving faster, right? Not the not only the force affects it, but the force and the distance both together affects the, you know, the whole circular motion, right? Get it? Right. So how do you calculate it? Where's that curve? This. No, not that one. Right. So how are you going to calculate it? That's the next question. Right. How are you going to calculate it? Right. So how are you going to calculate it? Now this is how you calculate it. So this is the pivot point and the distance in a d distance perpendicular to the d distance. There is a force acting here, right? So if I take the moment as tau, now this is a symbol of tau, right? This is a symbol of tau. So the tau equals to F into the perpendicular distance perpendicular d. You don't have to write this symbol, but like Fd is enough. I just pointed out that it should be perpendicular, right? So if you are taking the, you know, the torque, you have to multiply the force and the perpendicular distance, that you get the torque, right? So if I take it in values, let's say this is 10 newtons in a 2 meter of a distance, the torque will be how much? 10 newtons into d distance is 2 meters, how much? 20 Newton meters of a rotation. And as same as the force, it has a direction, but the you know, the force has like linear directions. Now this is rotating. So what are the two directions that, yeah, the clockwise and the anti-clockwise. So this is moving towards where? The clock, it is anti-clockwise, right? So this is moving anti-clockwise direction, that we can label it like this. Now this is the anti-clockwise direction. Get it? So it is measured in Newton meters, right? And now what happens if I apply the same force in a halfway of the previous distance, like 1 meters, like let's say the length here now is 1 meters. Now the length is 1 meters from the pivot point, right? It's halfway. So it's acting somewhere, the force is acting somewhere here, but the same value 10 newtons, right? Now the distance is 1 meters, that is half the d, right? So the torque now is F into d, which is 10 newtons. Now the length is decreased 1 meters. Now what is the torque? 10 Newton meters, right? And acting towards the same direction, right? Now there is a difference, isn't there? Now this is moving really fast, get it? This is moving slower than this one. Why? The torques are different, get it? The torques are different, right? So it's not only the force, the distance also affects, right? Because the forces are same. That is the point that what I want to point out. Do you get it? Like it's not only the force, also the distance affects the, you know, the rotation when it comes to the circular motion. Get it? Right. So that is one thing. Yeah. Yes, I'm coming to there. Right? Or like the right. So that is one thing. And if two of the torques, right? Listen. If the two of the torques are acting towards same direction like the forces, if the two of the forces are acting towards the same direction on the same object, how do you get the resultant? If the two of the forces are acting towards the same direction on the same object, you get the resultant by adding two of the forces. Same way, if the two torques are acting, you know, let's say this is D1 and this is F1, and this length is D2 and this is F2. Now two of the forces are acting, but the rotations are towards the same direction, right? So there are two torques. One is F2 into D2 is one torque, right? The other torque is F1 into D1, right? And the two of the torques are acting towards the same direction. So how would be the rotation? Would it be speeding or slowing? it would be speeding than the other one, right? Because two of the torques are there and the two of the torques are acting towards the same direction, right? So the sigma torque, right? Sigma torque, the resultant torque, right? Resultant torque would be F1 d1 plus F2 d2. Same like the forces, because they are acting towards the same direction, so they are added together, right? Simple. If you take the stimulation, it will show the same home source, right? Okay, the source, right? The source is on, right? So I'm gonna put like now this is one weight, no? Look at this, huh? So I'm adding only one weight. So it is moving like this, right? I'm gonna add two weights, but can't add together. So I'm gonna do something like this. I'm gonna add one weight like this, and the other one like this, 8 and 4. I'm gonna add a somewhere in the edge, right? Now you remember the speed when this was moving with one block, right? It was really slow. So I'm gonna remove this now. Is it faster or this is slower? It is faster. This one is slower. Now tell me the honest opinion. What did you see? Like, was it fast or slow? Fast or slow? You tell me, fast or slow? It was fast, right? Than the previous one, like with the one brick. Now this is faster. Look at it again. It brings back. So I'm going to remove this. Now this is faster compared to this one alone, right? See, it is faster compared to one block. Why is it faster? Because now it has two torques instead of one. So like two torques are added together, so makes a greater resultant torque to make the movement more faster, right? That's what the simple theory is. Now where is that circle? Can't find it. It's there. Right. Right. So when the two of the torques are towards the same direction, you add them together. And what if the two of the torques are like acting opposite to each other, like this? Now this is the pivot point. One force is, let's say it's F1 acting upwards, the other one is acting downwards. Sorry. The other one is acting downwards, F2 in a d2 distance. Here the length is d1. Now tell me, what would be the resultant torque? Would this be speeding or slowing? This would be slowing, right? Because two of the torques are acting towards the opposite directions. Get it? So two of the forces are acting opposite direction. So the resultant would be sigma torque equals what? Yes. Usually you take it this way. If the two forces are acting opposite, take one direction as plus, the other is minus, right? So like generally you take the anti-clockwise plus, the clockwise minus. It's easy, right? So better you write it like this. You are taking anti-clockwise as plus, clockwise as minus, right? Clockwise as minus. This is minus. මෙන්න මේක උඩ තිබ්බනම් හරි. එතකොට එහෙනම් මේක කියන්න බලන්න. Usually write the anti-clockwise rotations first. So here the anti-clockwise rotation is what? F1 d1, right? F1 d1 minus F2 d2, right? This is the resultant. So if I apply the values, let's say this is 10 newtons in a 2 meters. Here it's 2 meters. right? And this is, let's say, again 10 newtons, but in a 1 meter of a distance, right? So F1 D1 will be 10 into 10 newtons into 2 meters minus F2 is 10 newtons into 1 meter. So it will be 20 minus 10, which is 10 plus or minus now? Yeah. No, it's plus, right? So it's plus means the resultant will be towards the anti-clockwise direction, because always if we take the anti-clockwise as plus, if the resultant is plus, that means the resultant is acting towards the anti-clockwise direction. If you take the the clockwise as minus and you get the answer in minus value, that means the resultant will be rotating towards the clockwise direction, right? Simple as that. Okay, now come to the workbook. You get the whole theory, right? This is the basic of simple rotations or the moments. Now check this one. Right, find the resultant moment around point A. Right, do the first 4. Yeah, do the first 4 calculations quickly. Don't take time. Bro, no eating allowed in the class. That's fine, you take that one. Because අර කූඹි එහෙම ඇවිල්ලා සෙට් වුණොත් ඉතින් අයින් කරන්න බෑ ලේසි එකට මල කරදරේ. Yeah. Yes. Yes. නෑ නෑ. ඕ හැමතිස්සෙම pivot point එකේ ඉඳන් force එක තියෙන distance එක තමයි ගන්න. මේක මෙතන ගත්තා කියලා එහෙම මේට විතරක් නෑ. Pivot point to the distance to the force. Right? හතරම ගන්න. නා. direction එක දාන්න ඕන. clockwise ද anti clockwise ද කියලා දාන්න ඕන. ඔව්. කමන්නේ. නැත්නම් ෆයිනල් ආන්සර් එකට දාන්න. ලේසි. ඔව් ෆයිනල් ආන්සර් එකට දාන්න ඩිරෙක්ෂන් එක. clockwise ද anti clockwise ද කියලා. Done? Done? Right? So if I show you how the oppositely acting torques are working. හරි torques දෙකක් oppositely act කරනවා නම් it will be something like this. හරි දැන් මේකේ අපි අපි යන මෙයාව දාමු. හරි එයා 60 kilogram right. දැන් මෙයාගේ torque එක තියෙන්නේ කොයි පැත්තටද? clockwise ද anti clockwise ද? This is clockwise, right? So I'm going to put a greater mass than him, 80, right? So let's check what happens. Now she is in a length of here, right? So he should be somewhere here, right? දැන් මොකක්ද උනේ? මෙයාගෙන් ආවා anti clockwise torque එකක්. So it was greater than this one. So the resultant was now towards the yes. So if you take the ruler, right? So now what is the woman's torque here? The distance from the pivot point is 1.75 into 600 newtons. Can someone tell me the value? 1050, right? So here the torque will be 1.75 meters, and the Newton is how much? 600 newtons, and the resultant, sorry, the torque is 1050 Newton meters, right? Towards where? Clockwise direction. And here, what happens here? It's 1.5, ne? Yeah. So 800 newtons acting in a 1.5 meter of a distance. What is the torque here? 1200 newton meters. Right? So 1200, right? 10,000, not 10,200. So it's 1200 Newton meters. So this is greater than this one. So the resultant is towards where? The anti-clockwise direction. And what would be the resultant? 1200 minus 1050, which is how much? Bro, 150 Newton meters towards where? The resultant moment is 150 Newton meters anti-clockwise. Get it? Right. This is easy, right? Okay. Now come to the tute. Bro, where's that circle? I'm always missing it. The circle is there. Right. So, right. Now come to the question. Right. Now answer this. So tau equals FD. You have to write the formula because there will be separate marks added for the formulas, right? So what is F here now? 100 newtons, and the D is 5 meters, and the answer is 500 Newton meters acting towards where? Clockwise direction. Yes, That was easy. And this one, tau equals F D. F is 100 newtons, D is 4 meters, and the answer is 400 Newton meters acting towards where? Anti-clockwise direction. Get it? Simple, right? Now this one. So this has a resultant, right? So sigma tau. Now the sigma tau equals here 200 Newton into 10 meter distance plus 100 newtons into 5 meter distance, and altogether 2500 Newton meters acting where? The clockwise direction, right? And here, now this one is important because two of the forces are acting oppositely to each other. Now when two of the torques are acting opposite, what did I say? Take the anti-clockwise as plus, the clockwise as minus. Always write the anti-clockwise first, and then add the and then deduct the clockwise values. And if you get a like a plus value, that means the resultant is towards the anti-clockwise direction. If you get a minus value, that means you get a resultant of clockwise direction here. Anti-clockwise plus, clockwise minus. That's minus means the direction. Yeah, because because the minus values or the clockwise values are greater. That's why the final answer is minus. So that means the resultant should be towards the minus direction or the clockwise direction. So it's moving clockwise. Get it? Now check this one. So sigma tau equals what do we write first? The anti-clockwise values or the plus values, right? What are the first values here? 300 newtons into 10 meters, right? This is a plus value, and you deduct the minus value or the clockwise direction value. 100 into 5 meters, 100 newtons into 5 meters, right? So this is 3000, this is 500, and deduct it, you get 2500 of a plus value, right? 2500 Newton meters of a plus value. What does this mean now? Plus value. It means the resultant rotation is towards where? The anti-clockwise direction. So you draw it like this. Get it? Right? Done? Done? Got the same answers? Last one is different. What happened? You added them together? You added them together? Oh, direction එක වෙනස්. ඒ කියන්නේ ඔයා minus minus කියලා නම් තියන්නේ anti clockwise එක. එතකොට තමයි minus value එක. Doesn't matter. ඒක අවුලක් නැහැ. ඒක අර මං කිව්ව අර කලින් ඒතර ඔයා anti clockwise එක minus ගන්නවා කියලා මාක් කරන්න. එතකොට හරි. Doesn't matter. ඒක අවුලක් නැහැ. මම අර එක pattern එකක් තියාගෙන යන්නේ නැහැ. ඒතර හැමෝම මේ විදිහට හදනකොට ලේසි. නැත්තම් දෙගොල්ලකට එන උත්තර දෙක. එතකොට ආපහු පැටලෙනවා. Right? Done? Bros in the back. You done? Got the idea? Yeah. Right. So we're gonna go for the next part. Now tell me this, right? As I told you, the force and the distance should be perpendicular to each other, right? What if a force is acting in a in an angle, right? Not perpendicular but in an angle like this one. let's say this is the pivot point. Now this is the distance, and the force is acting in a, let's say, 30 degrees or theta degrees of angle from the horizontal plane. Now this is theta degrees, and the force is now not perpendicular to the distance. What happens here? And I'm like giving this force to this. Let's say this is a stick. I'm just giving this force to the stick in this point towards this direction. And would there be a rotation still, or wouldn't there be any rotation or a circular motion? If I give the force in an angle, would there still be a rotation or not? Would it rotate or not if I give the force in an angle? I'm going to give the force in an angle like this. What happens? Tractor start කරන දැකලා නේද? එහෙම රෙද්දක් එහෙම උතලා අදින්නේ. ඒක rotate වෙනවද නේද? 3 wheel එක. Rotate වෙනවද නැද්ද? It is rotating. It is going to rotate, right? But would the torque be F into D or something else? Is the torque F into D? Yes, right. මේකෙදී මෙහෙම angle එකකින් අපි මේක අද්දාම පස්සේ torque will be less than F into D. Do you get it? Because the force now here is acting in an angle, so for the rotation it has to be perpendicular to each other, right? So only the perpendicular force creates the the rotational motion. So there's a component of this one acting perpendicular to the distance, right? Which is we can take as a component. What would be the component of F towards the y-axis? Sine, right? So away from the angle it is sine. So F sine theta of a force is acting perpendicular to the distance, and it is less than the F, right? Because F sine theta is less than the F. Now this force is causing the rotation, Now this force is causing the torque. So it would be lesser than the Fd, right? Now the real torque here is Fd sine theta. Do you get it?
So okay, force එක දැන් මෙහෙටනේ ඔබ දීලානේ. ඔබ මෙහෙට දුන්නා නම් force එක
මෙහෙටද?
ඔව්.
ඒතකොට මේකේ ඩිරෙක්ෂන් එක
පල්ලෙහාට දුන්නොත්
මෙහෙම තිබ්බොත්.
ඔව්.
එතකොට ඔයාලට මෙන්න මෙහෙම මෙහෙට ගත්තා නම් හරි.
එතකොට ගන්නනේ අතනින් අරයට හැදෙන්නේ
නෑ. ඕන්න ඉතින් මේකම තමයි. එතකොට මෙයාගේ sin θ ම තමයි ඒත්. හැබැයි ඩිරෙක්ෂන් එක විතරයි මාරු වෙන්නේ.
එතකොට එයාගේ ගන්න ඕනේ මෙතන පල්ලෙහාට එන එකද ගන්න ඕනේ.
නෑ. පල්ලෙහාට ගන්න ඕනේ නෑ. මේකම අරකම ගන්න පුළුවන්. හැබැයි මෙයාගේ ෆෝස් එක දැන් ඇක් කරන්නේ කොහෙටද? ඩිරෙක්ෂන් එක. දැන් ඩිරෙක්ෂන් එක තියෙන්නේ කොහෙටද? මෙයාගේ කම්පෝනන්ට් එකේ ඩිරෙක්ෂන් එක තියෙන්නේ පල්ලෙහාට. ඔව්. ඒත් සයින් මතම දාන්න වෙන්නේ. හැබැයි මෙයාගේ ඩිරෙක්ෂන් එක මොකක්ද වෙන්නේ? ඩිරෙක්ෂන් එක වෙනස් වෙනවා. කලින් ගියේ ඇන්ටි ක්ලොක්වයිස්, දැන් යන්නේ ක්ලොක්වයිස්. That is only difference. Right? So දැන් මේකේ එහෙනම් right මෙහෙමනේ යන්නේ. මේකේ එහෙනම් අපි කොහොමද ටෝක් එක ගන්නෙ? So the torque will be equal to F into D, sorry, F sin theta into D, right? F sin theta into D. The torque will be F sin theta into D, right? අපිට මේක රීකන්ස්ට්‍රක්ට් කරන්න පුළුවන් කොහොමද? මේක කොහොමද මල්ටිප්ලිකේෂන් එක ගන්නේ? 2 into 3 කිව්වත් එකයි 2 into 3 කිව්වත් එකයි 3 into 2 කිව්වත් එකයි. So F D sin theta කියලා අපිට මේක රීකන්ස්ට්‍රක්ට් කරන්න පුළුවන්. This is one of the formulas you have to use, right? So whatsoever like මේකෙදී අපි sin වෙන්න පුළුවන්. මෙතන ඇන්ගල් එක දීලා තිබ්බොතින් මේක θ කියලා ගන්න ඕන. හරි. එහෙම ඉන්නේ සාමාන්‍යයෙන් මේක පාවිච්චි වෙන ෆෝමියුලා එක මේ වගේ මේකේ FD sin θ එකෙන් තමයි වැඩිපුර question එක. But that the thing that you should know is we took the component which is perpendicular to the distance. That's all. Get it? එතකොට මෙතන θ ආවොතින් ඔයා ගන්න ඕන මොකද්ද? මේ θ එක වෙනකොට මේ θ දීලා තිබ්බොතින් you have to take the cos value because the cos value is the perpendicular component now. Get it? මේක දෙන්නේ නැතුව ඔයාට මේක දීලා තිබ්බොතින් මේ angle එක දෙන්නේ නැතුව මෙතන angle එක දීලා තියෙනවා. මෙන්න මේක දීලා තියෙනවා. whatever. මෙන්න මේ angle එක දීලා තියෙනවා. θ එක. දැන් ගන්න ඕන මොකද්ද? f cos theta, right? හැබැයි සාමාන්‍ය ෆෝමියුලා එක දීලා තියෙන ස්ටෑන්ඩඩ් ෆෝමියුලා එක f d sin theta කියන එක, but the sin theta was from here, right? We took the component, that's all. Get it? Right, now come to the workbook. Come to the workbook. Right. Now these two questions are homework. Huh? Do this at home. මේකේ resultant එක ගන්න තියෙන්නේ. Now come to the, tell me the page number, this one, 9, right? Come to the page number 9. Do the first 4 questions in the page number 9. Right? Now who choose are these?
මේක මොකක්ද කියලා අහනවානේ. ඉතින් මේක අහන්නේ මේ friction forces what is the tensile strength connection එකට මේක පැය ගන්න. එතකොට ඉස්සෙල්ලාම මේ system එකේ acceleration එක හෙව්වා.
හරි.
ඊට පස්සේ මේ
isolate කරන object එක.
මේ මෙතනින් එහාට මේක මේ ඊට මෙහෙට කරලා ගන්න විදිහ හරියට එන්නේ ආන්සර්.
ඕකේ පොඩි අවුලක් තියෙනවානේ. මම හිතන්නේ පොඩි අවුලක් තියෙනවා ඒ ගානේ. මේකනේ මේ එක acceleration එක. මෙයාට වෙන වෙනම දාලා බැලුවද?
ඉතින් වෙන වෙනම දැන් මත් එකනේ.
එකම ඉන්නේ. ඒ කියන්නේ ආන්සර් එක. මෙයාට දාලා විතරද බැලුවේ? අනිත් එකකට දාලා බලන්න. මෙයාටත් දාලා බලන්න, මෙයාටත් දාලා බලන්න.
මේක එනවා මේක ඇඩ් ඔයද වෙන්නේ නේ ඇඩ් නේද මේ මයිනස් වුණා මේක මයිනස් වුණා මේ ආන්සර් එක මේක මයිනස් වුණා මෙතනට තව ෆෝස් එකක් කරා මෙතනට තව ෆෝස් එකක් තියෙනවා
මයිනස් වෙන්න බෑ දාන්න අපෝ
ටීක්
පොඩි අවුලකුත් තිබ්බා මට මතකයි ඔය ඔය ඒකනේ හරි එතකොට m1f නෑ නේ m1f m මේක ෆෝත් ආන්සර්
ඉතින් මේ පැත්තට දාද්දී එක ගන්න m2 කියලා නේද ඒක m2 කියලා
ඒක තමයි දැන් ඒක ආන්සර් එක දීලා තියෙන්නේ m1ට m2 වලින් දැම්ම ඩිෆරන්ට් ආන්සර් ගන්න එන්නේ ඔව්
උදේ ෆයිනල් ආන්සර් මේක වෙන්නේ
නෑ දැන් m2 එකට දැම්මම මේක එනවද නෑනේ
මෙහෙම්මම ආවේ නෑ
ඒක තමයි මේක තමයි එහෙනම් එන්නේ ඒක ගන්නට මෙනවනේ මෙයාට දැම්මම ඒක තමයි එන්නේ එතකොට ඒක මේක දෙකටම එකකට දාලා නතර වෙන්න එපා දෙකටම දාලා බලන්න අනිත් එක මේකේ ලේසි මොකද්ද
මේකේ ටෙන්ෂන් එක විතර තියෙන එකට
ඒකට තමයි මුලින් දාන්න ඕන right done no and guys you should know that we are the first class to start the the teaching with stimulations these ones those yeah so I haven't seen any of the teachers using stimulations yet no one is using not even for SFT, even for physics, I'm the first teacher to start it. And there's one teacher here doing physics. Now he's also doing, so we both started together. You know, the first time I was trying to create these stimulations using Blender. I told you, right? I'm like using Blender. Now there's Blender software. It like you can make the stimulations using the Blender. So I was trying to make the simulations using the Blender first. And even the videos. Danushka. Yes. And even the videos, we are the first people to like to explain the theories using the practical videos, the real case scenarios. And I'm the first teacher to do that as well. So those two things. No, you don't need to. I was just saying that, you know, because people will be copying this very soon. They are copying it. So I should have told you that I'm the first to start it. තව ටික දවසක් යනකොට බලන්න ඔක අනිවාර්යෙන් කොපි කරලා තියෙනවා. ඈ? එයා නම් තව සෑහෙන කාලයකයි ඔය වගේ කොපි කරන්නේ. නෑ ඊට වඩා ඇඩ්වාන්ස් කරන කට්ටිය ඉන්නවනේ. සාමාන්‍යයෙන් වීඩියෝස් වලින් වදිනවනේ තියටි එක. අර අපි ලෙග් ප්‍රෙස් අනම්මන වීඩියෝ කලේ. ඊට පස්සේ දැන් අපි මේ ළඟදී ගිහිල්ලා ලිෆ්ට් එකේ එහෙමත් වීඩියෝ එකක් ගෙව්වේ. ඒ වීඩියෝස් එකෙන් තියටි එක සාමාන්‍යයෙන් යනව නේද ඔළුවට. නිකන් එකට වඩා යනවා. සිද්ධිය තේරෙනවනේ. මොකක් හරි වෙනවයි කියලා නිකන් අඩුවනේ කියුරියසිටි එක හරියනවා. real case scenarios. So we produced, like we did a recording where at Havelock City about one of the motion questions of a accelerating system. To find the tension of a accelerating system, there's a weight, and the same way the same way affects in an elevator. For the weight, the total weight is get affected by the the accelerating system. When you are in an accelerating system, your weight gets affected. So there's a way of calculating it, and you'll be getting the questions. We'll be doing it in a few minutes. That type of question. Okay, अंतिम हरी तीनों. The rotation motion එක ඉවරෙච්ච ගමන් ඊළඟට තියෙන්නේ ඒක pulling system එක ගැන. ඒකේ එකක් practical එකක් තමයි අපි කරේ. මම ඒක හදලා දාන්නම් ඉක්මනට. Yes, yeah. You done? Are you done or you're done with the questions? You have a question? Ask me to come here. Yeah, what? Oh, I don't know about your cat. So what's the value here? 1000 root 3. It's root 3. So 1000 root 3 into 10 into root 3 over 2. පුළුවන් මල්ටිප්ලිකේෂන් එකක් තියෙනවා මේක පහ කරන්න පුළුවන්. Addition එකක් තිබුණින් බෑ. If there was addition you can't. So this is the so the cal gives 6061.5 or something. No, there is an issue with this one. So that's how usually the the mobile phone cals are. So they are not made for the the calculating. So that one gives the correct answer. It gives 15,000, yeah? Yeah. So there are issues with the phones. No worry about it. Right? Yeah. Oh. You have to put the direction. Right? Right, listen. So here you have to take the perpendicular force of this, right? The component. The perpendicular component you have to take, right? So it should be here, this, right? So what is the perpendicular component here? 1000 root 2 into sine 45. So sine 45 is how much? So this is 1000 root 2 into sine 45. of a value, right? So how are you going to simplify this one, right? So this is the force now, right? This is the force causing the torque, right, or the moment, not this one. This is the force causing the torque. So if I take tau equals Fd sine theta, now the force is 1000 root 2 and the d is 5 meters, and sine 45 is root 1 over root 2, right? Sine 45 is 1 over root 2. So root 2 to root 2 cancels out. 1000 into 5 is 5000 Newton meters, and it is acting anticlockwise, right? And this one, the force acting here should be how much? 1000 root 3, how much? Sine 60, right? Sine 60. And the tau equals Fd sine theta. F is 1000 root 3, right? Into d is 10 meters. And the sine theta is sine 60, which is root 3 over 2. Root 3 over 2, right? So what happens here? Now this is a complete multiplication, right? So when you multiply root 3 by root 3, what happens? The root cancels out. So you get a 3, right? So you divide 10 by 2, that is 5. Now this is 3 into 5 is 15. 15 into 1000 is 15,000 Newton meters. And the direction is anti-clockwise, right? Now come to this one. The perpendicular force causing the moment is 100 sine 30, right? So tau equals Fd. Now F is 100 Fd sine theta. I had to put the complete one, sine theta. So 100 into d is 4 meters sine 30. Now sine 30 is half, right? I'm gonna write it as half. So it will be 200 Newton meters clockwise, right? Clockwise. What about this one? The force acting perpendicular is 100 sine 60. So the tau equals Fd sine theta, that is 60. Now the force is 100 newtons, d is 4 meters, sine 60 is root 3 over 2. So the final answer will be 200 root 3 Newton meters. You don't have to simplify the last one. Keep it in search, that's fine. Right? And the direction is clockwise, right? Clockwise. Get it? Yeah, fine. Even that's fine, but most of the MCQs will be in search. And if you are doing an essay, that you have to put in decimals.
How can we convert decimals into cents?
You can't. You don't have to do that. Most probably you won't have to do that because it never has happened it. Usually you don't convert any decimals into certs. You convert decimal like the certs into decimals, that's all. Because there's no point doing that. Yeah. Right. And come to this point, right? Now there's one important theory here. Right? So this is here now is a simple theory, right? But when it comes to the real questions, this will only be one part of it, right? That simple thing will be only one part of it. So you'll really have to understand it and keep it in your mind when you are doing the questions, right? So this is a theory. So if a force is acting in the pivot point, on the pivot point, let's say this is A and B, and two of the forces are there. FA and FB, right? Now the pivot point is here. This is the pivot point, and there is a force acting on the pivot point. Would the force acting on the pivot point affect the circular motion or the rotation? No, right? Because there is no distance from the pivot point to the FA force. So there is no distance, so there is no rotation, right? So we can cancel this out, right? So only the torque is affected by the FB force, right? Not the FA. FA can be cancelled out. This is important when it comes to the equilibrium. When it comes to the equilibrium says if an object is under the equilibrium, you can take the resultant torque from any of the point over the stick, right? Let's say there's a stick like this, and they say it's under the equilibrium. මේක under equilibrium කියලා තියෙනවා. Forces තියෙනවා එක එක පැති වලට. මෙහෙට තියෙනවා, මෙහෙට තියෙනවා, මෙහෙට තියෙනවා, පහු මෙහෙට තියෙනවා. Likewise, the forces are everywhere, and this is under an equilibrium. And in the equilibrium, the theory is if it is under the equilibrium, at any point, right? At any point, if you take the resultant torque, it will be 0, which means you can take the resultant torque from here. You can take the pivot point from here. Even if you want, you can take the pivot point from here as well. Even if you want, you can take it from here as well. You can take the pivot point at any point that you want, all over the stick. And still, if you take the resultant torque by taking the rotations, the torques towards the left and right, and you add together, and finally the answer will be 0, right? So ඔයාට මේක equilibrium එකක තියෙනවා නම් ඕන point එකකින් torque එක ගන්න පුළුවන්. And the resultant will be 0 because it's under equilibrium. හරි. එතකොට ඔයා ඒ වගේ වෙලාවක සමහරක් වෙලාවට ඔයාට මේකේ resultant එක හොයන්න මොකක් හරි අපි හිතමු unknown force එකක් දෙනවා කියලා. මෙතන forces දෙකක් තියෙනවා. FA දීලා තියෙනවා. ඊට පස්සේ මෙයා දීලා තියෙනවා FB කියලා. So you are asked to find one of the forces, either FA or FB. Now if you take the pivot point from somewhere middle, FA and FB both will be taken into calculation, right? මොකද FA එක දැන් pivot point එක මැද්දෙන් ගත්තොත් FA එකත් අහු වෙනවා, FB එකත් අහු වෙනවා. So there are two unknown factors. If there are two unknown factors in a formula, can you get an answer? No, because there are two unknown factors. You have to isolate it into one, right? So the best thing is if it is said that this is under an equilibrium, you can take the pivot point at any point that you wish, right? So the best thing is if the two unknown forces are given, take the pivot point on one of the forces. So if you take the pivot point here, if A can be cancelled out because there is no effect. So now if you take the resultant torque, only the FB will be unknown. So you can simply calculate and find it. Get it? Simple as that, right? Now do the question here. Two of the questions. මෙතන මේක lazy, but there will be questions, you know. Do this too. Done? Done? Finish? You anybody? Ladies in the back. You done? There's only one. Do it. What did I? Yeah. Shall we check this one? So now it's now here the pivot point is A, right? So the force acting on upon the pivot point is not affected, right? So you can cancel it out. So tau equals what? Fd. Now F is 100 newtons and the D is 5 meters, and 500 Newton meters is the torque, right? So that is towards where? The clockwise direction. Yes. Yes. You have to mark the direction, right? So come to this one. The pivot point now is here. So the force upon the pivot point doesn't affect the rotation, so we can cancel it out. And now the torque equals what? Fd, and the force is 200 newtons, distance is 5 meters, you get 1000 Newton meters clockwise, right? That's it. Easy, right? So that's all about the rotations. Now that's all for now, right? There are the questions.
How can that be clockwise?
Because here it's rotating towards your right hand side. Now the pivot point is here. Always you take the rotation from the pivot point, yeah, to the direction of force, right? Right? Done? So there will be more questions when it comes to the equilibrium, right? So hopefully maybe, yeah.
Can we get that like always plus answers half or plus?
Yeah, even that's fine. You just have to mention it. That's all. And finally, when you have like a minus value, depending on the direction you took, you can select if it is either clockwise or anti-clockwise. That's simple. Yeah, that's fine. Because you know, like there's no such hard and fast rule for that.
So like
Just you can select it.
if we didn't mention the direction, are you going to get marks or something?
Sort of like, because how do you? Yeah, because yeah, you had to anyway mention one of the directions. So you know, like adding the plus and minuses make it easy to find the direction. Otherwise, you have to like separately find the direction apart from the calculating, right? Now here you don't have to think of it, because like in the calculation, if you get a plus value, that's the one direction. If you get a minus one, that is the other direction. So you don't have to worry about the direction when you are like putting plus and minus value. That's all, right? Right. So come to the pulley. Now this is very important. Now this theory you have to learn very much, that this sometimes, right? This will come to many of the questions that we'll be having in the future. So focus as much as possible and try to understand. This is simple, not a very like a hard sort of a theory. It's a really easy theory that you have to understand it. That's all, right? So in an accelerating system, right? In an accelerating system, they are asking to find the tension. This is one type of a question, right? So many of the questions were there from this type, right? So this sort of a questions comes under the systems that are accelerating, right? These type of questions are coming under the systems that are accelerating. That could be an elevator that we did the practical on, right? So we did a practical on this thing. Now this is a separate question, and we did another type of the same theory. Like we did another practical in the same theory in Havelock. We tried to go in a lift elevator with a a digital scale, and we were trying to to identify would the accelerating system affect our weight or not. So we took a scale, we stepped on it, and the scale was moving, the elevator was moving, and the weight was actually affecting. So when it was like the elevator was moving up, the weight was different, and when the elevator was moving down, again the weight was a different value. So can you tell, like, if when you are moving up, would the weight increase or decrease, or would it not affect at all? What would happen if you are accelerating upwards? Would the weight be increasing or decreasing, or would be same? What did you say? When you are going up or down? When you are going up, the weight is increasing. We did a practical on that, and we are going to publish the video very soon. Then you can see it, right? I have it here, but they are raw, like it's not edited. So yeah, like me දාන්න බැරිවත් තියෙනවා මම හිතන්නේ ඒකේ. So can't. I'll edit it and show you. Still the raw materials are still there. Right. So now if you are given a accelerating system and asked to find the tension of the rope, right? Something like this. Let's say this is 30 kilograms and this is 20 kilograms, and a force of, let's say, 150 newtons are acting. So no friction, no any other forces, right? Only the 150 newtons of a force is acting to the system, and they are asking for the tension of the rope right in the middle. So in a rope, the tension is acting towards two ways, right? Which is this and this, right? So what are these two tensions? Let's say you are like pulling a system like this with two of the weights. Right? මෙහෙම දාලා අදිනවා. මෙහෙම අදිනකොට there's one force that you feel like acting opposite, right? When you are pulling the object, the two of the objects like connected in a rope, when you are pulling it, that you feel sort of a force is acting opposite the motion, right? One force is acting opposite to the motion that you are pulling, right? That is this one, right? මෙහෙම අදිනකොට ඔයාට නිකන් අර පොඩි resistance එකක් දැනෙනවනේ. That is this one, right? Acting opposite. And the other tension is pulling the next object connected to it, right? ඔයා මේ ඉස්සරහා object එක අදිනකොට අර rope එකේ tension එක ඔයාට පොඩි resistance එකක් දෙනවා. හරි. ඒ resistance එකේ තියෙන ඒ tension එකම තමයි next object එක නැත්නම් මෙයාව අදින්නේ. See? මෙයාව අදින්නේ කවුද? Is the same tension, right? So these two tensions are same, they are equal in values, and it's the same tension. Get it? So in a rope, two of the tensions are acting opposite directions. That is why when you cut it, the rope will go two sides, right? It will move either ways. It doesn't go towards one way or other, right? It moves either ways because the forces are acting opposite, right? Right. So you are asked to find the tension. So in order to find the tension, you have to go through these three steps, right? These three simple steps you have to take. First one is find the acceleration of the system, right? Find the acceleration of the system is the first thing. Second one is isolate the object, right? Shall I do the first first one first. Now you have to find the acceleration of the system. To find the acceleration of the system, you have to put what? Sigma f equals ma, right? You have to put sigma f equals ma. Get it? Right. So what is sigma f here? What is sigma f here? 150 newtons, right? Because there is no any other friction or anything, right? There is only 150 newtons of a force. Get it? And the whole system is moving, so the whole mass of the system is affecting the resultant or the acceleration, right? The first day I told you, like, the acceleration of an object is affected by the resultant force and the complete mass of it, right? So here it's the same. The acceleration of the system is affected by the resultant force, which is 150 newtons, and the mass, right? So we are putting sigma f equals ma to the complete system, which is with two of the masses, right? So what are the two masses? 30 and 20. So you have to take two of the masses to get the complete acceleration. So what is the complete mass here now? 30 plus 20, which is 50 kilograms. The complete mass is 50 kilograms. Then you have to find the acceleration, which is how much? 3 ms minus 2. Get it? Now that is the acceleration of the whole system. 3 ms minus 2. Get it? Yes. The second thing what you have to do is isolate the object. Isolate any of the object that you feel to, to find the tension. You can isolate any of the objects, right? Either this one or this one, right? Isolate the object and label the forces, right? You have to label the forces. So I am going to isolate this one, 30 kilograms of mass, right? So this is the first step. I am done with the first step. Now I am doing the second. So I am going to isolate one of the objects. I am going to isolate this one, 30 kilogram of mass. So tell me now, what are the forces acting on 30 kilogram of a mass? Only on the 30 kilogram of a mass, right? So what are the forces acting here? Is 150 newtons of force is acting on the 30 kilograms of mass? Yes. So 150 newtons is there. So now don't worry about the weight and the reaction. They are all equal. So doesn't affect the motion, right? Only the forces in the x-axis affects the motion here now, because it doesn't move up or down, right? So the up and down forces should be equal. So you don't even have to mark the forces in the the vertical axis, right? Because it doesn't affect the horizontal motion. Get it? You don't have to mention those two forces. Then what else? What are the forces? There is another force acting opposite to the motion, which is the tension, right? So these are the two forces. Get it? So the last thing what you have to do is, right? The last thing what you have to do is put F equals ma to the object to find the unknown force, right? Put, this is sigma f, right? Sigma f equals ma to find the unknown force, right? To find the unknown force. Get it? So how do you put sigma f equals ma to this object? Now we already have found the acceleration, which is 3 ms minus 2. So this object is moving in acceleration of 3 ms minus 2, right? So we are going to put the sigma f equals ma to this object now, right? So tell me, what is the sigma f here now? Girls in the back, tell. What is the sigma f here? What is the resultant force of this two forces? 5? No, I am asking the resultant force acting on this object. Do you see any forces acting on the object? So what are the two forces acting on the object? 150 and Is there a 30? No. The tension, right? Two of the forces acting on the object are 150 newtons of a force, which is the pulling force, and the other one is tension acting opposite for the the motion. Those are the two forces acting. And how do you get the resultant of this? How do you get the resultant? If two forces are acting opposite to each other, you deduct it, right? You deduct it. So what do you deduct by what? If there are two forces and if one is larger, you deduct the lesser one from the larger one, right? So you have to take the larger one first. So which one is larger, 150 or T? 150 is larger because it's moving towards its direction, right? So the resultant here will be of these two forces 150 minus T. And what is the mass? 30 kilograms. And the acceleration of that mass is the same acceleration of the system. What? 3 ms minus 2. Right? 3 ms minus 2. So you have to simplify this now. 30 into 3 is 90. And you take minus t to the other side, that becomes plus t. So you take the 90 towards this way, that becomes minus 90. So 150 minus 90 equals t, right? 150 minus 90 is what? 60 newtons. Now what is the tension of the rope now? 60 newtons, right? So this is one way. The same thing, like three of the same, the rules can be applied to this object as well. මේ object එකට දාන්න පුළුවන්. අපි දැම්මේ කාටද? 30 kg. ඕන 20 kg ට දාන්නත් පුළුවන්. 20 kg ට දැම්මොත් කොහොමද දෙන්නේ බලන්න? So if you are going to apply this to the 20 kg of weight, right? Now this is 20 kilograms, right? And what are the forces acting on the 20 kilograms of weight? What are the forces acting on the 20 kilograms of weight? Tension force, right? Is there any other forces? No, only the tension force, right? So the tension is acting here, T, right? So in order to find the tension here, now we found the acceleration in the first rule. The second one is isolate the object and label the forces. Now we have isolated the 20 kilogram one, and the only force acting on the object is T, so we have labeled it. Now what do you have to do? Put the sigma F equals ma to find the unknown force, right? So how do you do it now? You put sigma F equals ma now. So what is sigma F here? The only force acting on the object is T. So T equals mass is 20 kilograms into acceleration is 3 ms minus 2. So what will be the answer? 60 newtons. Get it? Isn't it the same answer? It's the same answer, right? So it's because it's the same rope. If it is the same rope, it has to have the same tension, right? If it is the same rope, it has to have the same tension. So yeah, you understood it, or yes, right? So if it is the same rope, it has to have the same tension, right? So either you can find it using the 30 kilogram weight or the 20 kilogram weight, right? No, you have to find, select either the 30 or 20. Which one is easier, the 30 or the 20? Actually the 20 is easy, right? Because it has only one force to act. Get it? Right. Now this is the whole thing, right? Come to the workbook and may put a sticky note on this. Put a sticky note. Or if you don't have a sticky note, write it in somewhere in the boxes. You will have to have sticky notes by now. I have asked you. I have brought. Thank you. You brought it? She brought for yourself also. That's fine. So none of the subjects are easy, right? There's this thing that you should understand. If someone says so, if something feels like it's easy, there's a rule, but you're doing it wrong. Right? Yes. If you feel it's easy and I can do this, it's you're doing it wrong, right? You have to understand that. Hi, I gave you the number. Because she has a wedding. I think she's getting married. But after the marriage, she'll start. Even after the marriage? Okay. I know that's a dumb. I can't tell anything because it's recording. I'll find another person. Because she's the teacher that Saira people gave me, you know. That's your, huh? No, that's SFT, you know. BST teacher or something. Yeah, that one. Yeah. Bro, I don't know. I'm not gonna support afterwards if he didn't start for you people. Huh? Who? Why? Bro. Let's see about that. It's fine because BST is much easier relatively to the other subjects because as far as I know, I don't know. I think compared to, I don't know, it depends because people are different, right? Oh. සාමාන්‍ය BST teachers ලගේ ඒ කියන්නේ lab එකක් නැහැ. lab එක නැතුණට ඒගොල්ලෝ practicals එක කරනවා. ඒගොල්ලෝ කරනවා. ඒ කියන්නේ after the දැන් ඔය විරාජ්‍යම් ගන්න after the ඉස්කෝලේ තියෙනවා. ඉස්කෝලේ ගිහිල්ලා කරන්නත් පුළුවන්. Oh, you can there's one thing that you can do. You can request the English medium paper and still be in the class.
Still staying in the school.
Yes, and request the paper in English medium.
The school is not taking the responsibility, so they're
That's fine.
to stay.
ඒ private කරනකොට තමයි අයින් වෙනවා. That depends on the the principals. Yeah. So if a good principal is there, then usually they gives Then the Peters එකේ now there are Peters එකේ හරි මට මතකද Peters එකේ ශක්තිය කියන Peters එකේ 3 දෙනෙක්. ඒ 3 දෙනාටම ස්කූල් එකකින් දීලා තියෙන්නේ. ඒගොල්ලෝ ස්කූල් යනවා. ස්කූල් එකේ වාල්ලා ඉන්නවා ඉංග්‍රීසි මීඩියම් ස්කූල් එකේ සිංහල මීඩියම් තියෙන්නේ. පේපර් එක ලියන්න දෙනවා. No, not the ඒව සිංහලෙන් හම්බෙන්නේ. But the final paper will be on and even the provincial paper, I think. Provincial එකේ English එක නැද්ද? Then only the A-level paper. So about the practicals, teachers are doing it. The private teachers are doing it. You don't have to go to the school because බෑ එයාට ඉස්කෝලට ගන්න බෑ ඔයගොල්ලෝ. can't because that's a boys school. That's a complete boys school and it's against the yeah. කවුද ඉන්නේ? කවුද මෙයා ඉන්නේ ප්‍රින්සිපල් නෙමෙයි. Section head කවුද ඉන්නේ? Aziz. Aziz will. So I know somehow Aziz won't allow. Though even the principal allowed, the Aziz won't allow for sure. Right, done. Come to the first question. Do it real quick. Read it. Good. Do the first question. Find the tension. And do the second one as well. What were the answers? 72 and 72, right? 72 was the answer, right?
Yes.
For the first one, yes. Good. Ow. අපි 26 කට්ටියවත් අරන් යන් කොහේ හරි. දැන් 25 කට්ටිය අපි ගියා කොහෙද හැව්ලොක් ගියා හැව්ලොක් විතරයි ඒක මහා ලොකු එකක් නෑ නෙමෙයි. අපි ට්‍රිප් එකක් පස්සේ යන්. 25 කට්ටියව දාන් යන්න බෑ. එතකොට එන ඔයගොල්ලෝ එක්සෑම් එකෙන් පස්සේ. ඔයගොල්ලෝ එක්සෑම් එකෙන් පස්සේ. ඔව්. මැද ගියොත් එනවා. එතකොට අර මේ ට්‍රැක් එක කැඩෙනවා. නෑ නෑ කපල යන්න. බයයි. අරන් තමයි. අපි අර වගේ ක්ලබ් එකක් දාමු ඕන්න. දැන් එදා අපි හැව්ලොක් එකට ගියාන් පස්සේ මං හිතන් ඉන්නේ මම ඕක කරනවායි කියලා. හැබැයි ඕගොල්ලෝ ඒක අරගෙන කරානේ. Oh, that's a good thing. ඒ කියන්නේ අර ඕගොල්ලෝ පබ්ලික් එකෙන් questions අහලා එහෙම කරානේ. But okay. Akif and Safir. Yeah. The under course was different, but they did it somehow. they did it somehow. We have the videos, right? We have the proof. But anyways, that was good, you know, like asking the questions from the public, and they might know the physics. They don't know actually. There's one actress as well, right? Eh? Oh. Who the Akitma? Yes. Income. So ඒක හොඳයි. ඒ කියන්නේ awareness නේ. දැන් ඔය ගොඩක් අයට ඒක lift එක යනකොට weight එක වෙනස් වෙනවද කියන එක ගැනවත් idea එකක් නෑ. Even all the videos that I put are like about the misconceptions that people don't understand it. අර leg press එකත් එහෙමයි. leg press එකේ මම කිව්වේ leg press එක press කරනකොට ඒගොල්ලෝ හිතන් ඉන්නේ දාන මුළු weight එක මේගොල්ලෝ press කරනවා කියලා. But actually only they are pressing is a component of the whole thing, right? Not the whole weight. So that's a misconception. Even in the lift, that they gave the different answers. They told that when the lift is moving upwards, some people told it the weight doesn't change, and some people said the weight reduces. You know, different answers were there, and mostly they are the misconceptions. They don't know it, and they think it differently. They have like their own theory in their head. This happens because of this, sort of. So we're making that clear, right? So that's something good. That you do it, something really good, because that's, you know, the students doing it. That is one way of making people understanding by the students is really nice, something really good, because that's why you are learning, to make the people who don't know understand it, right? Or to find something that others can't do to help them. So it's really good. So I'm going to continue a few videos by myself of some of the things, and I'm going to give you people a chance as well to go to the public and speak with the the audience, right? And ask the questions and make the clarifications, and we make some videos on that. අරගෙත් අපි එහෙම questions අහලා ඊට පස්සේ lift එකේ අපි practical එකක් කරා. කරලා බැලුවා. ඒකේ weight change එකක් වුණා නේ. V ගෙන ආවා ඊට පස්සේ අපි පොඩ්ඩක් ඒක alter කරා. ඔව් චුට්ටක් එහාට මෙහාට වුණා. So there was a difference, yes. Supposed to be a difference. මම හිතන්නේ අර ඒ කියන්නේ උඩට යනකොට acceleration එක අඩුයි. ඔව් පේන්නේ. අන්න හරි. ඔව් ඔව්. කට්ටක් තියෙන එක ගත්තා නම් හරි. මේකේ slow. මේකේ ලොකු acceleration යන්නේ නැහැ. හරි පේන්නේ නැහැ. අරක ටිකක් හයියෙන් යනවනේ. මේකේ කරොත් acceleration එක ලොකුවට තේරෙන්නේ නැහැ. අරක ඈ ඊට වඩා හයියෙන් යනවද? එතකොට හයියෙන් යනවා. අන්න ඒ වගේ එකක් තමයි ගන්න ඕන. ඒක හයියෙන් ගියා. ඒකේ මම හිතන්නේ මේ reduce වෙනකොට 5-6 කිලෝග්‍රෑම් reduce වුණා. ගොඩක් reduce වුණා. 5-6 කිලෝග්‍රෑම් කියනවද ගාන? 2 වගේ ගියා. 52 වගේ ගිහලා තිබ්බේ. Right? So what were the answers? What was the answer for the 72 newtons? Did you do the second question as well? Yeah. So what were the answers for the 10 kilogram mass of tension? 30 newtons. Did you all get the same? 30 newtons. And the second string? 60. Make it heavy then. Take it away. Now the first one is 72. The second one? 10 kilogram. This one is 30. This is 30. This one? 60. 90. Oh, hammer rope එකකම. Of the same tension it's equal, but there are two ropes, so different tensions. Oh, you can ඔයාට මේකට දාන්න පුළුවන් මේකට දාන්න පුළුවන්, that's fine. 10 හෙව්වනේ 30 කියලා ඒක. මේකට දාලා මේක හොයන්න පුළුවන් මේකට දාලා මේක හොයන්න පුළුවන්. Right? Yeah.
මේක ගත්තා ඉස්සෙල්ලම. ඊට පස්සේ දැන් මෙතන මේක හොයන්න මේකට කෙලින්ම දාලා ගන්න බෑනේ නේද මේක
මේක දන්නවනම් පුළුවන්.
මේක ගත්තා.
එතන මේකෙන් ගන්න.
T2 - T3 කියලා මේක ගන්න.
පුළුවන්. ඔව් ඒකෙන් ගන්න. මේකට දැම්මොත් මේ දෙක තාම එකක්වත් දන්නේ නැහැ.
ඔව් ඒක තමයි. එතන එකකින් එකක් අඩු කරලා නේද ගන්න.
ඔව් එකක් දැනගන්න ඕන. 20
ගත්තත් එක මාසෙක තමයි දෙන්නේ.
ඔව්
මේකට එන එකම නේද?
ඔව් ඒ කියන්නේ
ගන්නොත් එමෙ දෙන්නටත් තියෙනවා.
ඔව් ඒ කියන්නේ same rope have the same tension.
හරි බලන්න මෑස් එක 20යි. ඇක්සලරේෂන් එක 5යි. අනිත් දඩ ෆෝස් එක මෙතන P ගන්න මෑස් 20යි 60 නිව්ටන්. මේක තමයි. පොඩ්ඩක් හල්ලුව. මේකනේ කියන්නේ ටෝන් එකේ සිග්මා equals n. ෆෝස් එක කියන්නේ මෙතන T1 T2 කියලා ගන්න.
Right, done with the second one as well. So what were the tensions? First one 30, the second one 60. Anyone who got a different answer? Same answer, 30 and 60. Same. Make a 30, make a 90. You have 90. මෙතනටද? ඒ කියන්නේ මේ rope එකේ tension දෙකක් තියෙනවානේ මෙහෙම. You can find either any of it, doesn't matter. අපි ඒක T1 කියලා ගමු. It will be same නේ. මේක T2. So what was T2? 30. And the T1? 90. You have 60. I'll check that, right? So I'm going to do the math here now. Right, listen. So first we have to find the acceleration, right? Put the sigma f equals ma to the system, right? So what is sigma f here? 108 Newton, because that's the only force acting here. But what if there were like friction forces? Yeah, if there were any frictional forces, you have to deduct them, right? මෙතන 30 10 වගේ තිබ්බොත් ඒක 180 වෙන deduct වෙනවා. But there is no force, so the only force is acting 180. The complete system is moving, so the complete mass should be taken 30 20 10 is 60 kilogram, right? And into the acceleration. So the acceleration is how much now? 3 ms minus 2, right? That is the acceleration. So you have to isolate the each the masses to find the tension, right? So to find the T2, it's easy to isolate the 10 kilogram of mass, right? So I'm going to isolate the 10 kilogram of mass, which has the tension of T2 and the acceleration of 3 ms minus 2. So I'm going to put F equals ma, because there's only one force F. So F is T2, mass is 10 kilograms, the acceleration is 3 ms minus 2. So the tension 2 will be 30 newtons, that is correct. So again then I have to find the T1. You can either isolate 20 or 30, that doesn't matter. Which did you isolate, 30 or the 20? එහෙම බෑ. T1 minus T2 කියලා ගත්ත T1 දන්නේ නැහැ.
නේද? මමයි. නේද මේක දන්නවනේ.
මෙයා දන්නවා.
ඔව් ඒක එතකොට මෙහෙට නැතිද යන්නේ?
ඔව්.
එතන T1 minus T2 නේද T2 එක දන්නවනේ.
හරි.
එහෙම ආන්සර් එක දාලා ගත්තම එනවා 60යි. අරක 30 කට isolate කරලා දෙවම 90 එනවා.
Can't be. Has to be the same answer. Then someone කොහොමද හැදී 20 ට දැම්මේ 30 ටද? 20. 20. Has of those who put it to the 20 had the answer 60. And hands of those who put to the 30 kilogram? 30 get 90, no, bro, can't happen. Right? Now listen. So how do you do it? So I'm going to put to the 20 first, right? Now here's a 20 kilogram of mass. And the forces acting is T1 is acting here, T2 is acting here, right? These are the two of the forces, T1 and T2. Right? So this is T2, this is T1. And the acceleration is how much? 3 ms minus 2, right? So how are you gonna put the sigma f equals me? Now sigma f is equal to me. Now tell me what is sigma f here? You know T2 already, right? T1 we are trying to find. Bro, which one is greater, T1 or T2? T1 is greater because the system is moving towards that way. So the T1 should be greater. So the difference is T1 minus T2. Hands up those who put the correct weight, T1 minus T2. Fine. You did 20 kilograms or 30 kilograms? Did you put T1 minus T2 or T2 minus T1? How did you put the difference, the resultant force? කොහොමද ගත්තේ අනිත් පැත්තටද? ඒ කියන්නේ T1 වලින් T2 අඩු කරාද T2 වලින් T1 අඩු කරාද? 20 එකටද දැම්මේ රිසල්ටන්ට් එක. ඔව් 20 kilograms weight එකට තමයි isolate කරන්න යාව. එතකොට මෙතන sigma f කියලා ගත්තේ මොකද්ද? ඒකේ එන්න ඕන T1 minus අපි මෙතන T2 හොයාගත්තානේ. කීයද 30. එතකොට T1 minus 30 newtons තමයි resultant force එක. එහෙමද ගත්තේ? 30 into
3 into 20.
bro that's a different නෑ no. ඒ කියන්නේ අර එකකින් එකට එහෙම නිකන් දැම්මද? Bro you can't do it like that. That's only for the the last object. Yeah, because it doesn't have any other forces. If there are any other forces, you have to take the resultant force. ඔගොල්ලෝ දාලා තියෙන්නේ නිකම්ම 20 එක 3ms minus 2 වලින් multiply කරලා. You can't do it like that. Because there are two forces acting. In this one, in 10 kilograms of mass, there's only one force. So if you put sigma f equals sigma, there's only one f, right? But in this case, it has two forces. So you have to take the resultant, which causes the acceleration, right? Right. Now you understood, right? So T1 minus 30 equals 20 kilograms into the acceleration 3ms minus 2, right? So this is 60 minus 30 goes the other way, it becomes plus 30. So T1 is how much? 90 newtons. Yeah, that is 90 newtons. If there are two forces acting on the object, you have to consider the two of the forces because that's the resultant, and resultant causes the acceleration. Right? And even if you put the other way, listen, even if you put the other way, it will be the same, to this object, 30 kilogram eකට දැම්මොත් same answer will be there. නේ? 30? Pull up. You try it. It will be the same answer. Hmm. හතලියට දාන්න නැතුව 30ටයි 20ටයි දාන්න බෑ. ඇයි? Either you have to know at least one of the forces acting on the object. දැන් මෙයාට දැම්මොත් ඔයාලට මෙයාව හොයාගන්න පුළුවන්. මේක දන්නවනම් මේක හොයාගන්න පුළුවන්. මේක දන්නවනම් මේක හොයාගන්න පුළුවන්. නැත්නම් මේක දන්න හින්දා මේක හොයාගන්නත් පුළුවන්. ඒතර ඔබ්ජෙක්ට් එකක එක ෆෝස් එකක් හරි දැනගන්න ඕන. ඔව්. දාන්න ඕන. ඔව්. The only object with one force is 40. For the rest of all the ones, you have to put sigma f equals sigma. So there has to be two forces. Considering this way, adduction has to be considered, right? Oh, there's no other way, bro. So this is there are some other ways, but standard method is this, right? Right? You first do these questions. Now there are some other things inside the the theory that you multiplied the 20 by 3, that you got 60 newtons. What do you think that is? If you think it is complicated, don't think of it. I'm just saying If you multiply this by 3, you got 60, no? That's the resultant force on the object. That's the resultant force on the object. Get it? Because resultant force causes the mass to accelerate. So if you multiply the acceleration by the mass, that is the resultant force you get, not the acting, yeah. Get it? So the force difference here is 60, that is what you got. Right, now this is homework. You do it at home, huh? This one, last one. Always the last one is homework. Right? Right, so even you can do these questions as well, but we'll finish these questions in the next week, right? Yeah. Okay, so then for today the class is finished. Do the homework. Make it. Make it. Make it. Can't do it now. Next week. I think you ask it personally. You ask it personally. White board එක ලියපෙකද? White board ලියපෙකද? මේමයි. Okay, thank you. Let them do it. Yep. මේක මේ ස්ටොප් කරලා